Yeah, your class. It's fine to tell your class this. The answers for closure are in your book. So if you would like to check your closure, like that's why most often we don't do it together. So I'm on Math 7 Schoology, but it's pretty much the same. So if you go to the ebook, I made the announcement. I remembered. You're welcome.
I forgot about it.
Then I got told that I didn't know what I was talking about because there's Harry Potter Club. And I was like, look, this is just what I've been told. So, if you want, oh wait, it was CC3. So, my bad, I keep bouncing around books. So, in CC3, Chapter 5, if you go to closure, the answers are there. Boom. Alright, so, we have been talking about, okay, I was so excited to jump into the problem. We have requests. This is why I have to plan things out, because I forget. So one request from 711 is part C here. So if you would look at 711, yours might be done. We did check those answers, but this person probably didn't have it done when we checked, and then they realized, ooh, this is kind of tough. I want to make sure I know what I'm doing correctly. So I want to encourage that if you guys work together, you really don't need me. Like, I am really unnecessary here. Like, when I'm like sick, I have to tell myself that. Like, the kids don't need me. They just like need to do math. Can anyone help me with C? Harrison?
You have to combine like terms.
What is going to determine like terms?
The variables and coefficients.
So 7x squared. What's another? What else should I highlight green?
7x squared.
I already did. I'm just teasing. Sorry. All right, so that's gonna get 14x squared. Then 3x. What else should I highlight yellow?
3x.
I already did.
The other one.
It's not funny the second time.
I see. Some of you guys keep repeating things off the internet, and we're like, guys, it's not funny anymore.
Yeah.
No.
And then if I highlight my
And then
plus
the other
4,
one. The other one. The other one too. Don't forget the other one. Don't make it sad.
there you go. That's as simplified as you can get. Oh, sorry, I didn't highlight. That's what you were yelling me about.
Yeah.
Oh no, now it's green.
You gotta fix it.
Oh, I
We-
must.
I don't like you. This is mean.
I'm telling my therapist on you.
Same. I'm telling my therapist too.
Okay, we're good.
Alright, there we go.
Go to therapy too.
I'm the one who has a bad heart. You
Me
guys aren't
too.
old enough to talk about heart
I've
attacks.
got her too.
Have you had surgery yet?
Yes.
Like the whole.
Yeah, like 5 months old.
It's real. Wow. Okay, I was an adult, but that's crazy that they can do that to babies too. It's real weird when your doctor's like, and then we'll crack your chest open and just break your rib cage, and I was like, bro, that's how we do it. I'm like, okay. All right, 714. Mr. Anderson's doctor says he needs to reduce his caloric intake. Go on a diet, my bud. So, 15% reduction is what we're looking for. One way to do this, since it asks for 2 ways, would be like do subtraction, right? Figure out 15% of his regular caloric intake, what's the general, what should you be taking in each day? How many calories? Do you guys know? 2,000. It's about 2,000 is roughly what they say we're supposed to eat per day. So if we could figure this out, hey guys, what's 10% here?
280.
What's half of that for 5%?
140.
So what is 15%?
420.
420, right? So we could subtract that from 2,800, or the better method we talked about yesterday,
Which is figure out.
the quicker way. Lydia,
Find 85%.
why 85%?
Because 100 minus 15 is 85.
So this is how much he's going to actually end up wanting to eat. And of course, like, I've used a calculator. I just didn't feel like it up there, and we're smart enough. We don't need to use one up here. 46. You guys, these are not just random. People emailed me, right? So thank you for making the requests. If you were the people that made the request, because it sure looks like classmates are needing these problems also. A dwarf lemon tree grew half as much as a semi-dwarf. A full size grew 3 times as much as the semi-dwarf. How many trees are we talking about here? 3. That's the trap door. They give us 2 sentences about the trees. Well, 3, I guess. But they both reference the semi. So we have the dwarf tree, and I'll write out an equation for that. We have the full-size tree. I will write out an equation for that. And then we have, what else?
The regular dwarf lemon tree.
We got the dwarf, we got the full,
Semi.
the semi, but they didn't tell me an equation for that.
Well, it grew half as much as the semi, which is a third of the lemon.
Don't start using, like, you'd end up circling, if you make semi, no, so the dwarf was half the semi, right? So we're using S. The full size, they say what?
3 times 3.
So we're using S. So when we talk about S, use S to talk about S. And then you still got math to do. If you leave it like this, I'll know you just copied from me in class. You still got math to do. There's still work to do, but I'm not doing the rest of that for you. Enrique is stating to buy a graphing calculator, which you guys don't really need these days because Desmos does a lot of that for you. Well, Desmos can do all of it for you pretty much. He has saved $30, and that is 40%. The $30 is 40%. We need to figure out the 100%. There's a lot of different ways that we could do this. In my brain, I kind of think, well, how do I go from 40 to 100? How can I turn 40% into 100%? But I don't know what 60% is to add 60%. So you're like, I could, but I don't know what 60% is. Vivian?
I would times 30 by 2 to get 80%.
What could we multiply by to go all the way to 100 though? You're right, times 2 and a half, right? So if we take this times 2 and a half, we'll figure out how much that calculator supposedly costs. They're more expensive than that. This answer is not. CPM normally has like accurate like stories and math and like references of like Mount McKinley is 20,000 meters tall. Like that's normally true. This is not true. A graphing calculator costs like $150 these days. Yeah, because money is worth less than it used to be. Like this kind of color graphing calculator, not color as in it's pink, the screen shows color, is like $150 these days. I think we had another. No, I just figured we could check homeworks. So also, I'm not going to take a long time with this because I see that a lot of you are still doing these homeworks, but it is recorded, right? So if you need to go back and check your answers again, but those were all the requests that we had. So here's our answers for 711. You could pause the video on that if you are needing to use this to check, but please don't just cheat your way through. You're only going to hurt yourself. 712. Yeah, you could talk in hours or minutes if you wanted to convert for that boat trip problem. Tree diagram, if you forget how to make a tree diagram, it's really more so like a root diagram, if you ask me, because when I draw them, they go down and they look like the roots of the tree. But a tree diagram, you don't have to draw it like this. You could draw, I go vertical with my tree diagrams. They went sideways, but I go vertical. Up to you. 713. Box plot. Sorry, stem and leaf. So you're looking at 713. Guys, when you look at that problem, I hope you had the reaction of like, what? There's a lot of numbers. That's the point of using a stem and leaf. A stem and leaf, if we don't remember, because I feel like every year kids are saying like, oh yeah, we remember how to do that. Secretly, they're like, what the heck? I haven't done this in a while. Your leaf is only ever the ones place. Your stem is everything else. This lets us organize our data. So before any of this would happen, you just literally say, my lowest number is 100 something. So I'm going to start my stem at 10, then 11, then 12. And we put all of the stems to get to our highest number. Like, let's say we didn't have any 110s. We still put that stem. We just then would not put any leaves over here. Oh, I'm on the wrong, okay. I know, I just forgot that last class I was writing on it with the ink layer and that let me erase. So then, 10, 6 is really what number? 106. 12, 6 is what number? 126. 14, 2 is actually what number? 142. Then, guys, hold on, I'm going to blow your mind. See this?
Yeah.
Actually, I'm going to take a screenshot so this is actually like better. Because I said I was going to blow your mind, and you know, I can't over-promise and under-deliver. Anyone know what I'm going to do?
Yes.
Yeah.
I think.
What do you think I'm going to do, Carter?
I think you're gonna take like the numbers, like the amount of ones placed on the leaf plot, and turn that into like a box plot.
You're close. Stem and leaf plot.
What?
Histogram. Your stem and leaf is your histogram. It's the same thing. You just turn it. Guys, come on. Like, this is why we do a stem and leaf, is because then the histogram is easy. He said it. It's easy. Once you have your stem and leaf, you got your histogram. Had anyone seen that before? Was that like,
No.
I know I maybe didn't blow your mind, but come on. That's a
Oh, my
good
mind.
thing to
My
realize.
brain is
That your stem and leaf, literally turned sideways, is your histogram. Now remember, histogram, just like stem and leaf, you start wherever your lowest value is. You don't need to start at 0. Your bins, do not ask me why we call them bins. These are your bins. I did not make this, like, I did not determine this. Your bin width. If you look up histogram, it's going to talk about bin width. Your bin width is determined by you, however you want to sort your data. Since our stem and leaf went by tens, if we go by tens, it's the same thing. But here's the tricky part. You have to decide, like, if you had 100 as one of your data points, 100 can't go over here because you didn't leave a space over there. So 100 goes here, which means 110 would go in this bin. 120 would go in this bin, right? So like you have to make sure that if your numbers are dropping into the bin on the right, like your checkpoint numbers, right? 100, 110, 120. So this 130 and these 120s, right? Like those are in the bin to the right of it, right? So it's like, how many 130s do I have? 2 of them. Even though 130 is the line, right? Like 130 is marking that line, but it goes into the bin to the right. Question? I know I got too excited about this, but come on. It makes your life easier.
Very cool.
I saw some of your guys' faces of like, what did he? I haven't even drank all my coffee yet this morning.
I'm scared now.
It's game night tonight, guys. I get to play D&D tonight. That's why I'm excited.
Alright, that's fair.
Yeah, we haven't played a campaign in like a month. All right. Ooh, sorry. 714. I did not show 714. I talked about that problem. They show you the same thing. I talked about that problem. They use X instead of S. So there's our other answers. Hey, if you got the probability questions wrong, go back and rethink them. Don't just change your answer. Go back and rethink. Or is different than and. Or is easier than and. If I pull out dice and I start rolling, like what's easier? Getting 2 dice to, I guess I don't need those. Yeah, I did find my other big ones. It's like, what's easier, a 3 or a 5, or a 3 and a 5? 3 or 5. That's way easier. That's why that's a 1/3 chance versus a 1 out of 36. And if you need a probability reference page, I was going to rip it off the wall, but might as well show you guys. If you need a probability reference page, I know some of you can't reach, just ask me. I have deck of cards, because some of us like haven't had a ton of card deck experiences. 2 dice, right? It's weird. What's the most probable roll of 2 dice? 7, because it has the most ways to be made. So there's 2 different tables here showing about like why 7 is the most probable. So if you need a probability reference page, somebody should remind me. I should put that on Schoology too, just so you can easily get to it. Yeah, thanks. We have been talking about community service in foundations, right? We've been talking about one of your ideas for Discovery Day being service related. So let's talk this out through a math problem. Anyone want to read for us? Because also my throat kind of hurts now. I got too excited. No one wants to read. There are 20 of you, and no one will save me. It's on your paper. 715, community service. Lydia's going to read for us.
Alright, that's my Discovery Day.
I don't think so.
Community service. The Community Service Club at North Middle School is planning to paint apartments at the local senior citizen center next week. The club needs your help to determine how many apartments they should be able to paint in a day. Earlier in the year, when only 4/7 of the students worked, they painted 9 apartments in one day. Next week, all of the students are available. Assume that all of the student workers contribute equally to the work. If X represents the number of apartments that can be painted by all of the students in the club, use a multiplier and your understanding of scaling to represent the situation as an equation.
All right, so on your paper, this might look real funky. Like, you might not understand this diagram, and that's okay, because that's why we have class together. This is showing us what the problem just told us. So this is showing us 4/7 of x. I hate that I wrote my fraction like that. Actually, I'm just... Guys, because what am I going to do to solve? Who remembers from yesterday? How do I get rid of this fraction in a single step? Eva? The flippy fraction thing! Flippy fraction thing. Reciprocal.
No.
And we gotta do it on both sides. Now, if you are sitting there like going, like sure this works, but like why? Here's the why. If we multiply by 7. 1, 2, 3, 4. What's 4 times 7? 28. And then to just get 7/7, I would need to divide by 4, right? I would need to divide by 4 then. Like, what we're doing is multiply by 7. That would give us 28 of these little, like, things that are noting that, like, that was 4/7, right? These are people, but we don't know how many. So when we multiply by the reciprocal, it wipes out over here, gets just x. What's 9 times 7? Sorry, my computer's mad at me for some reason, and I'm just checking. All right, I just want to make sure that I was still recording because I don't know if you saw the spinny thing that like looked like something was loading, and I don't know what would be loading. 63. What's 1 times 4? 4. Ooh, what's 60 divided by 4? 15, right? Because it's 40 and another 20, so 15 and 3/4. Sorry, that 5 looks a little aggressive.
It's okay, Mr.
Do 53 and 54 with each other, like with your partners. How do we solve both of those? 54, you've got multiple options. Flippy fraction thing. Flippy fraction thing. I'm going to upload that probability page right now. Hey, in case you want to look at it, it was in our probability folder, but I also just put the probability reference sheet down here. So if you need a reminder about deck of cards type math or dice type math, you can come here, and especially with our dice rolling. This table's great, but it doesn't make sense to all of us of like, wait, okay, so that's 5. It's a 3 and a 2. So I love this table that color codes the dice. And, you know, it feels a little festive for the holiday. You know. 1B deck of cards. Will, help me with 53. On both sides. Flippy fraction thing. So wait, Lydia, you're making a face. Is it because my 3s look sloppy, or? No. So 2/3 was multiplied by x. Flippy fraction thing, reciprocal, will make, guys, let's make sure we understand why this is happening. It'll make 6 over 6x. What is 6 divided by 6? 1. So we get 1x. When we do it over here, you could cross reduce, or what's 8 times 3? Divided by 2. Flippy fraction thing. Chase, what about 54? Do you want to do it live? Show off your skills? I bet you can. How's 0.85 attached to x? Is it added, subtracted, multiplied? How do we undo multiplication? By what? What are we going to divide by? Yeah, some help from across the room. 0.85 on both sides. Guys, my hope, my wish is that like you'll be in high school, you'll be like doing algebra or even college or whatever, and just quietly, you'll just be like on both sides, and somebody like from a different grade will be like on both sides. Like that's my hope. Like that's my wish. Or well, okay, we haven't. That's new this year. That's you guys. But on both sides has been my thing for like years, because it's algebra. That is that's like the fundamental rule of algebra. Is if you do it on one side, you have to do it on the other side. You have to be fair. And real quick, before I give you the rest of the time to work on homework, and by the way, your practice work is just what's back here. In 63, Carter, what could we do here? And if you want a visual of it, I think this goes, yeah, because this is 4/3. This is 2/3 of x, right? This is the visual representation of this problem. But what can I do to make the whole thing way easier? And I should pick on Lydia just because of the conversation we had this morning. But Carter, your card's up.
Multiply everything by 3.
Because if everything's divided by the same thing, we can just get rid of it effectively. But the reason why is we multiplied by 3. right, Lydia? And then do we know how to solve it?
Yes.
Turn to a partner and discuss in 64 what is that first step that fixes everything. Or take a couple steps to figure out what to do. Are you guys on 64 or a different one?
63. Are we supposed to be on 64?
I mean, we can finish this, I guess, but like, yeah. So if we multiply by 3, all those divisions by 3 are gone. I guess we might as well finish this. Kyrie, what would I do up here? Sorry, we bounced back to 63 because I would like, some closure if we got that. So this is one of the fun ones. I would like us to subtract 4 first, but we don't have to. This works out that if Kyrie says, hey, divide everything by 2 right now, that's fine because 2x divided by 2 is x. 4 divided by 2. 10 divided by 2. I still have to subtract. But because all these were even, I'm able to do that. And what's x? 3. 3 hee hee. Is that Michael Jackson saying 3? All right, in 64, I want to go the long way. Madeline, what could 4 and 6 both get to a common denominator of? 12. Now, how many of you thought 24? It's okay if you did. So did I at first. So, to get to 12, you don't have to take the long way, but I am. And then my 7, I could make 7 go over 12. I'm going to. Let's do it. We get 3x over 12 minus 10 over 12 equals 7 times 12. Oh, come on. Somebody show off your mental skills. Rowan, now that everything's divided by 12, multiply by 12. I didn't leave you enough space, so now my work is going to get all messy. What now, Liam? Sorry, we moved over here. My work is getting kind of weird. What now? Add 10 on both sides. On both sides. And Kira, what do we do now? Divide by 3. 31 and a fourth?
31.3.
Yeah, which is... Oh, yeah, a third. Sorry, 31 and a third. Guys, the fraction is better than the repeating decimal. They're both right, but the fraction is better than a repeating decimal. You have the rest of the time to work on practice. I told you guys, I know I'm giving you a lot this week. I want to make sure that we're solid in these skills, but I'm giving you time. Madeline? Thank you for asking again. So, stuff from Thursday. In my old way of operating, which I'm still operating right now, but I think next week we might talk about changing things up a bit. So, Chapter 5 closure, which I don't know why I decided to write chapters, but 5 closure. If I already know I'm not going to like it, I can just do it. Y'all stole my markers. And then 711 to 714. So what? have them done, you may staple them and turn them in. Please put oldest on. Well, actually, leave chapter 5 closure separate, but staple your 7s together, right? So 7, 1, 1, 2, 3, and 4. Yeah, if you did work on graph paper, let me see that, please. Yeah, and you just want to keep those things together if they go together, right? All right, you guys still got 10 minutes to get some good work done. You're correct. Do you really dislike rounding or something? I'm going to laugh when you work a job that makes you approximate things. Like, it'll just be life's irony if you end up having to approximate stuff. What we just practiced of multiply both sides to destroy those denominators.
On both sides.
Yeah, like this was fraction busters.
On both sides.
It's CPR.
Fraction equals X. I solved the universe.
What do you mean fix it?
I solved it.
What do you got? This Bustos was a sweet show.
On both sides equals the universe. I think I was
So it has worked with some of you that have come to work with me, but I think some more of us still need to be brainwashed a bit more. Like I got a couple of your attentions. Homework help. When people come to ask me questions, like the number one thing I say first is, have you tried homework help first? Guys, I'm telling you, it's like 3 clicks away. It is amazingly useful. So like in 770, right, like how Kyrie just asked me, like, wait, what's Fraction Busters again? If I went there, because I wasn't quite sure about what's Fraction Busters again. Oh, hey, they show me what to do. Now, if that doesn't help brainwash you into believing that homework help is a useful tool. 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 Okay. That's...
I think homework help might be useful too.
I think that is helpful.
All right, keep working, guys.
Mr. Hudson, I solved string theory.
You need
fraction.
homework help?
Flippy fraction thing multiplied by on both sides equals universe.
You solved string theory?
Yeah.
Is that the only
Okay.
reason you have this string there?
No.
Theory from Young's
This is
law.
obviously the antenna on top of a house.
Obviously.
And these are obviously the guy wires. And yes,
Obviously.
they're called guy wires. I don't know why.
Why not woman wire?
I don't, dude. I literally just said I don't.
I was
And,
they were guys.
and this
Why are
is obviously going to get used for when we learn Pythagorean theorem. Well, duh. Obviously. Now the question is, why do I have 2 golf balls in here? And why are they not the same? Actually, if you want to see the cool thing that's in this drawer, give me your paper.
Wait, can I have one, please?
Not a whole bunch of.
Whoa! Look! It's like, it's embedded in the paper. We
My
feel it.
choir
It's so
director,
cool.
like I come from a really small town. Everyone like knows each other. So I did a lot of work for my choir director, like sorting music and cataloging stuff. And so this, I believe, is called an embosser, right? I think this is called embossed. And it says, I don't know, you guys are funny that you all like want one. It just says from the library of Micah Hudson. But like it was for my music, because I had hundreds of pieces of music because I was in choir for years. I don't think so, because it's bent the paper.
Yes.
It has like the paper is no longer flat.
Will it work the same on graph paper? I'm gonna make
What? I mean, yeah, it might cut it though, because graph paper's so thin.
Wait, can you do on the cover of my binder?
Oh, yes.
My
No, but if we're gonna get it on both sides, I need like a rubber stamp. You know what I mean? To do it, like,
I can also date you.
and these are really expensive.
He had
Like,
stamps.
please don't buy me something expensive.
I would.
I love gifts. I love gifts from kids, like, because it makes me feel good. Like, it really does. But like, please don't spend a lot of money. Like, I don't like it when kids spend a lot of money.
We need to Dennis Zella's like 27 and
What do you
seconds.
Yes.
I want everyone to be mastered.
We're getting Mrs.
That's
Ellis.
like saying I want peace on earth, right? Like, it's a big wish.
I want to get Mrs. Ellis a bunch of statues of Tchaikovsky because she's obsessed. It's gonna be really funny, and I'm just gonna hide them in
I'm
random
gonna
places
give
around
Miss
the
Callis the chaperone poster.
room. Yes.
Really cool name.
To replace the one that fell.
Yes.
R.I.P. R.I.P. the plankton
I'm
Cody
right
girl
on
one.
the corner in honor of wait, Olivia and Kelly. Was that?
Kelly and Olivia. Yeah, Olivia and Kelly. What? I think it was Olivia and Kelly who made the plankton.
You have 3 minutes left. That's accurate, Jack. You have 3 minutes left to still get work done if you want.